Hello everyone, this is microCTRL and welcome back to our Arduino tutorial series. In today's video, we're going to explore Lab 2 Basic Arduino Programming and solve simple but practical examples. Problems to be solved. Problem number 1. Write a sketch that applies bonus scores to given scores in the range of 1 to 9. The program reads a digit as an input. If the digit is between 1 and 3, the program multiplies it by 10. If it is between 4 and 6, multiplies it by 100. If it is between 7 and 9, multiplies it by 1000. If it is 0 or if the value is not a digit, the program must report an error. Create two program versions, one that uses a switch statement and the other one uses nested if-else statement, and at the end, print the calculated new value at the serial monitor. Let's jump into the code and see how we can implement this in Arduino. We were going to write two versions of the code, one using a switch statement and the other using nested if-else statement. This section initializes serial communication with a baud rate of 9600. We use this to communicate with the Arduino board via serial monitor in the Arduino IDE or any serial monitor software. This is the main loop of the program, where the Arduino continuously executes the code. It's where we handle user input and calculate bonus scores. This line prints a message to the serial monitor prompting the user to enter a digit score. This line waits until there is data available to read from the serial port. It ensures that the program doesn't proceed until the user entered some input. This line reads the entire input string from the serial port until a new line character /n is encountered. It stores the input as a string in the variable input string. This line checks if the input string is empty. If it is, it prints an error message and exits the loop. Similarly, there's another check to ensure that the input string contains only one character. If it contains more than one character, it's considered invalid, and an error message is printed. This line extracts the first character from the input string and stores it in a variable named input. This character represents the digit entered by the user. This line checks if the input character is a digit. If it is not, it prints an error message and exits the loop. This line converts the input character, which represents a digit, to its integer equivalent. This is done by subtracting the ASCII value of 0 from the ASCII value of the input character. This line checks if the input is within the valid range. In this section, we use a switch statement to handle different cases based on the input digit. If the digit is 1, 2, or 3, we multiply it by 10 to get the bonus score. If the digit is 4, 5, or 6, we multiply it by 100. And if the digit is 7, 8, or 9, we multiply it by 1000. The break statement is used to exit the switch statement after each case is executed. These lines print the calculated new scores to the serial monitor. The serial print function is used to print the message new score, and the serial print in function is used to print the actual new score followed by the new line character. Now, let's see how the code behaves with different inputs. We click verify. Now that we fix all the errors in the code, let's click verify again. Then upload. Done uploading. Then next, open the serial monitor. In the serial monitor, we see that it says enter digit score. Now let's see how the code behaves with different input. If we enter a digit between 1 and 3, we get a bonus score of 10 times the original score. For example, if we enter 1, the new score will be 10. If we enter 2, the new score will be 20. If we enter 3, the new score will be 30. Similarly, if we enter a digit between 4 and 6, we get a bonus score of 100 times the original score. For example, if we enter 4, we get 400. If we enter 5, the new score will be 500. If we enter 6, the new score will be 600. And if we enter a digit between 7 and 9, we get a bonus score of 1000 times the original score. For example, if we enter 7, we get 7000. If we enter 8, the new score will be 8000. If we enter 9, the new score will be 9000. If we enter 0 or a non-digit character, the code will report an error. For example, if we enter 0, it will show invalid. If we enter a character, example A, it will show invalid. If we enter a multi-digit number like 25, it will show invalid input. Next is using the if-else statements code. In this, most part of the codes is the same. They only differ in the bonus score calculation. In this section, we use nested if-else statements to check different conditions based on the input digit. If the digit is between 1 and 3, we multiply it by 10 to get the bonus score. If the digit is between 4 and 6, we multiply it by 100. And if the digit is between 7 and 9, we multiply it by 1000. Each if-else statement checks a specific range of digits, and only one of the blocks will be executed based on the condition. Now, let's see how the code behaves with different inputs. If we enter a digit between 1 and 3, we get a bonus score of 10 times the original score. For example, if we enter 1, the new score will be 10. If we enter 2, the new score will be 20. If we enter 3, the new score will be 30. Similarly, if we enter a digit between 4 and 6, we get a bonus score of 100 times the original score. For example, if we enter 4, the new score will be 400. If we enter 5, the new score will be 500. If we enter 6, the new score will be 600. And if we enter a digit between 7 and 9, we get a bonus score of 1000 times the original score. If we enter 7, the new score will be 7000. If we enter 8, the new score will be 8000. If we enter 9, the new score will be 9000. If we enter 0 or a non-digit character, the code will report an error. For example, if we enter 0, it will show invalid. If we enter a character, it will show invalid. If we enter a multi-digit number like 25, it will show invalid. And that is all for our solution to problem 1.
Now, here is the second problem. The colors red, blue, and yellow are known as the primary colors because they cannot be made by mixing other colors. When you mix two primary colors, you get a secondary color as shown here. When you mix red and blue, you get purple. When you mix red and yellow, you get orange. When you mix blue and yellow, you get green. Write a sketch that prompts the user to enter the names of two primary colors to mix. If the user enters anything other than red, blue, or yellow, the program should display an error message. Otherwise, the program should display the name of the secondary color that results by mixing two primary colors. With that, we will be using Arduino IDE to construct our code for this problem. First, we need to define the primary colors. Our primary colors are red, blue, and yellow. Next, let's create a function that will mix the two primary colors and will return the secondary colors. The secondary colors are purple, orange, and green. We already created a string. Now, we will be using the if, else if, and return function. As you can see, we have now created a function that will return the secondary color of the mixed primary colors. Now, we will use the setup function and initialize serial communication at 9600 baud. By initializing, the serial should print this message: choose two primary colors to mix, red, blue, yellow. For the loop function, the first thing we will code is to check if there are enough characters available in the serial buffer. It should read the input from the serial monitor. Next, we will trim the input to remove any leading or trailing white space. This next function is to split the input into two color names. Then, if no space found, we should display an error message, "Error, please enter two primary colors separated by a space." We will be creating two strings that will separate the input into two colors. Also, we will convert the chosen colors into lowercase to easily check the input. Next, we will use the bool function to check if the entered colors are primary colors. If either color is invalid, we will display an error message, "Error, invalid primary colors. Please enter only red, blue, or yellow." But if the color is valid, we will display the result with the message, "Mixing color 1 and color 2 produces the result." Lastly, we will print a message again to prompt the user for another set of colors. As you can see, we've already sketched a solution to problem number 2. By mixing red and blue, we get purple. By mixing red and yellow, we get orange. And by mixing blue and yellow, we get green. Also, you will receive an error message if you choose a color that is not one of the primary colors.
Now let us head over to problem number 3. Write a sketch that displays the following menu. If the user types small y or capital Y, then the program redisplays the menu and asks the user to enter their choice. Otherwise, the program should now exit. If the user enters 1, the program should ask for the radius of the circle and then display its area. use 3.14159 for pi and the radius of the circle for r. If the user enters 2, the program should ask for the length and width of the rectangle and then display the rectangle's area. If the user enters 3, the program should ask for the length of the triangle's base and its height, and then display its area. If the user enters 4, the program should end. Input validation. Display an error message if the user enters a number outside the range of 1 through 4 when selecting an item from the menu. Do not accept negative values for the circle's radius, the rectangle's length or width, or the triangle's base or height. Implement the program using functions on it. One function will be used to display the menu screen, and the other functions are for the different computations the program will have.
We now have problem number 3. I used PUP to test and run the code, and later we'll use the Arduino IDE. First, it says that we need the menu, which says Geometry Calculator, followed by 1. Calculate the area of a circle, 2. Calculate the area of a rectangle, 3. Calculate the area of a triangle, and lastly, 4. Quit, which is shown on lines 13 to 18. Line 1 to 2 is for the formula of the area of a circle, which is pi times radius squared. The value of pi that we use is 3.14159. Line 5 to 6 is for the formula of the area of a rectangle, which is length times width. Line 9 to 10 is for the formula of the area of a triangle, which is 1/2 or 0.5 times base times height. Next, the menu should ask the user to enter their choice from 1 to 4. Depending on what number the user types, it will lead them to another menu, which is shown on line 26 to line 28. If the user enters 1, the program should ask for the radius of the circle and then display its area, which is shown on line 33 to line 47. If the user enters 2, the program should ask the length and the width of the rectangle and then display its area, which is shown on line 49 to line 69. If the user enters 3, the program should ask for the length of the triangle's base and its height, and then display its area, which is shown on line 71 to line 91. If the user enters 4, the program shall end. During the menu, if the user enters a value outside 1 to 4, it will display invalid choice. Please enter a number between 1 and 4, which is shown on line 93 to line 100. Once the program is done solving the area, or if the user chose to quit, it will ask the user if they want to try again, which is shown on line 102 to line 111. We now have the code on the Arduino IDE. Let's verify and upload our code into the Arduino Uno. Now that it is verified and uploaded, let's try it on the serial monitor. It is currently showing the menu that we coded. Let's drag it up a bit to see it more clearly. For the area of a circle, type 1, then 1 for the radius. It showed us the radius that we typed and then the area. Let's type Y to try it again. As you can see, it brought us back to the menu. For the area of a rectangle, let's type 2. 1 for the length, then 2 for the width. It showed us the length and the width that we typed, and also its area. Let's type Y to try it again. Once again, it brought us back to the menu. For the area of a triangle, let's type 3. 1 for the base, then 2 for the height. It showed us the base and the height, and also its area. Let's try it again, but this time, let's try to type negatives. Type 1 for the area of a circle. Let's type -1 for the radius. It showed us an error message because we typed a negative value. Let's try rectangle this time. Let's type -1 for the length. And also -1 for the width. Again, it will show another error message because we entered negative values. Let's try it on triangle this time. Let's type -1 for the base and -1 also for the height. Once again, showed us an error message because we typed negative values. What if we type number that is not between 1 to 4? This time, let's type 0. It shows us an error message because it is not between 1 and 4. Let's try it with 5 this time. Again, it shows an error because it is not between 1 and 4. And lastly, we type 4, which is for quit, which exits the program. That is all for problem number 3.
So now, let's start demonstrating the sketch for the problem number 4, using Walkme first, then trying it on Arduino IDE after. First of all, let's analyze the problem. Write a sketch that prompts the user for 4 test grades. It will be used to determine if a student has earned an A, B, C, or F in the class, using the following grade cutoffs. If the grade is greater than or equal to 90%, the grade must be A. If it is 80 to 89.99%, it is B. If 70 to 79.99%, the grade is C. If the grade is 60 to 69.99%, it is D. And if it is less than 60%, it is F. A student can drop the lowest exam score of the 4 exam scores. Therefore, the program should find the average of the 3 highest grades and print this average. It should also print a message stating the letter grade they earned in the course. To truly test your program with data that calculates a grade for each letter grade. Also be sure that the lowest grade is not included in the calculation independent of whatever it is, the first, second, third, or fourth score entered by the user. So let's take this as an example. This is what we are going to do with this problem. The goal is to display several key metrics on the serial monitor. The lowest exam score out of 4 inputted values, the average score computed from the 3 highest values, and the corresponding grade for that average score. So, let's start creating the sketch for problem number 4. So, what we are going to type inside the setup function is serial communication with a baud rate of 9600 using the syntax serial.begin to allow communication from the Arduino to the computer and vice versa through a USB cable. After that, we're going to initialize 4 variables to hold the 4 scores that will be inputted by us later on. Each of these variables will be assigned as a float type since we're going to input float data. The first variable will be named score underscore highest with an initial value of 0. Also initializing the other variables to 0. Next, we will create a for loop for the looping of the input values. Here, we initialize the variable I to 1. It is assigned as integer, not a float, since we don't need its values in decimal form. Next, assign the iteration to stop if it is not less than or equal to 4. Lastly, we put the post increment there so that it will increment the value of I after one cycle happens, allowing us to track which exam score is currently being input. After that, I put the syntax that uses while loop and has a boolean condition true so that the program waits until a valid score is entered. What we are going to do next is use the serial.print notation to show the serial monitor what data they should input. Next, we will use the while not serial.available syntax so that the input buffer will not end until the user inputs data. As you can see, this notation uses while loop, and the not operator is added at the condition, so that if there is no available data to be read from the serial port buffer, the loop will not stop. The empty curly braces mean that there's no execution inside the loop, but only waits until there is input data. After that, we will create a string variable that holds the read data from the serial port buffer using the notation serial.readStringUntil. So, I named the string variable inputted_score, and it will hold the read data until a new line character is encountered, which is why there's \n inside this notation. After that, we will create a float variable to hold the converted read data. Name it conv_score, short for converted score. The inputted score data will be converted to a float by using the toFloat notation. Then, we will use the serial.println to show to the serial monitor the converted score, and we will proceed to a new line after. Now, we are going to create a conditional statement to sort out the 4 inputted values from highest to lowest. So, we can easily remove the lowest value and only get the average of the remaining values. First, let's type This statement means that if the converted score is greater than or equal to 0 and less than or equal to 100, basically numbers from 0 to 100, the execution inside the statement will happen. Otherwise, other thing will happen, which we will declare later. So, inside the statement, we are going to create a conditional statement again. This time, its purpose is to sort out the inputted values until all 4 required values are complete. This means that if the converted score is greater than or equal to the score_highest variable, then this execution will happen. First, the score_lowest will be equal to the score_third_highest, and so on. Basically, the variable that is holding the lower values will be replaced by copying the values of the variable one step higher, and the value of the converted score will be held by the variable that satisfies the condition. Let's input the other condition. Using else if condition for the extension of the first if statement that is not proven to be true. Here, where the condition is if the converted score is equal to or greater than the second highest and not equal to or greater than the highest score, only three variables were replaced, since the variable holding the highest score doesn't need to be swapped based on this particular condition. Next else if statement is it follows the same logic that if the converted score is greater than or equal to the third highest score but doesn't satisfy the first two conditions, then the variables holding the lowest score and the third highest score will only be replaced. Lastly, we are going to use the else statement as the closing condition. If the inputted data didn't pass on the first three conditions, the variable holding the lowest score will be replaced by it. Now, we are going to put a break statement to terminate the outer loop immediately once the values are already complete and proceed to the sketch after the loop. Now, we are going to input else statement if the converted score is not greater than or equal to 0 and less than or equal to 100. So, I only put serial.println here, which prints the string of data saying invalid, enter a number between 0 and 100. Now, let's go outside the while and for loops declared earlier and continue creating the code. The next thing we will do is to compute the average of the three highest scores, and we will declare a float type variable to hold the result. Here, I named the variable av_score, short for average score. Then, I get the values of the highest score, the second highest score, and the third highest score, compute their sum, and divide by 3 to get the average of those values. Now, what we are going to do is assign the grade counterpart of the computed average score by using conditional statements. Before that, let's declare a character variable named grade. Then, let's start creating the conditional statements. If the computed average score is greater than or equal to 90, then its grade counterpart is A. If it's not but still greater than or equal to 80, then its grade counterpart is B. If it didn't satisfy the first two conditions but is greater than or equal to 70, then the grade value is C. If it's greater than or equal to 60 but not equal to or greater than 70, then the grade value is D. Lastly, if it didn't satisfy all the previous conditions, then the grade value is F. Lastly, we are going to show the output values to the serial monitor using serial.print and serial.println notations. Finally, to end the sketch, let's put delay here so that the program will take a rest after a couple of milliseconds. I chose 1000 milliseconds, which equates to 1 second. Now, let's try this code here in Walkme first. Let's input dummy scores. And after completing the required values, the output will show the lowest values, the average of the three highest values, and the grade counterpart of the computed average. Now, let's try this in the Arduino IDE. And it still works.
Thank you for joining us to solve the following problems for our lab exercise 2 using Arduino simulators and the Arduino IDE. This has been microCTRL. See you in the next video.